Alright, so 5A. On our review sheet. Says, A cosine, x plus 3 pi. Alright, so my formula for the cosine of an angle plus an angle is cosine of the first, cosine of the second, minus sine of the first, sine of the second. So far, so good, just plugging in to my formula. Now, there's not much I can do with cosine x, but cosine 3 pi I can evaluate. So, what is the cosine of 3 pi? -1. And the sine of 3 pi is 0. So when I start simplifying, it looks like all I have left is negative cosine x, because that will go away. All right? You're welcome. Leo.
You're number 14.
14. So I'm going to have to do some kind of simplifying. Okay, so Leo, when I look at the problem, the first thing that occurs to me is the thing I'm simplifying into, which is this, is all signs. That's all signs. So, luckily, I can make that a sign. What does cosine squared equal? Sine squared, so 3 times 1 minus sine squared. Same thing on the right. Now, first glance, it looks like it's getting worse. But now that it's all signs, hopefully some things will cancel. So we have 3 minus 3 sine squared. Plus 5 sine minus 5. Would you agree that the top is really a mess? So let's clean that up a little bit. How did I do? Are you okay with that? What should we try next? Factoring. Now, I think I told you this before. I don't know what's wrong with me, but I have a really hard time factoring when that's a negative. So for me personally, you don't have to do this, you factor that, however you factor it. I'm gonna pull that negative out to give myself a fighting chance at factoring this thing. Because I don't this I can factor. This will be 3 sine. I can't lose the negative, it stays in the problem. But it doesn't have anything to do with my factoring. Does that look better? And what about the bottom? Can I do anything with the bottom? It's the difference of squares. Now, these two, the way I've done it, these two don't factor, or don't cancel, because they're not exactly the same. But if I put this negative back into this parentheses, so I have my 3 sine minus 2, and then I would have 1 minus sine. If I multiply this second parentheses by a negative, put that negative back in, and then I can cancel. question over it like I did.
Why do you not have to put the -1 for the 3 side?
Because it's not a distributive problem, it's a multiplication problem. If I take 2 times 3 times 5, I multiply the 2 times one of those numbers, but not both of them, right? There's no plus in there, it's not a distributive. Did anybody find anything else in 1 to 18? 6A. Sketch 1 period. In any of these pictures, well, sines and cosines may not so much, but everything else, I gotta remind myself what a regular curve looks like. So the regular tangent looks like that. So that's where I'm starting. That's the regular tangent. Now, what's going on in this one? Well, first of all, it's going to be upside down, right? And it's been phase shifted, that is moved to the right by over 11. Everybody agree with that? So there's going to be an asymptote over here and an asymptote over here. And it's going to be going down. All right. What is the period of the normal tangent? That is this distance right here. In normal tangent, the period is pi. In this guy, the period is pi over 2. That means from asymptote to asymptote is pi over 2. Now, that means that from here to, I don't know, the scale could be wrong. I may have to fix this in a minute. But this distance is pi over 2. Which means this distance is pi over 4. So to figure out what that is, I have to take my pi over 11, which is my starting point, and I'm going to add pi over 4. Is everybody understanding what's happening? The whole thing is pi over 2. So half of it is pi over 4. So what's that going to be? 15 pi over 44. Oh, my math, is that right? This is 4 pi over 44. Now, if I added 11/44 to go that way, then won't I subtract the same thing going this way? So that would be -7 pi over 44. Now notice, from -7 to 15 is 22. And 22/44 is exactly what I needed that distance to be. Right? Now, I know it's coming down. In a normal tangent, halfway in between, though I'm not going to label this point, although I could, I'm not going to, but halfway in between, I would be down 1. Because of that 4, now I'm going to be down 4, and over here, halfway in between, I'm going to be up 4. So my curve is going to be a lot steeper than it normally is. But it's going to come from up here, go through that point, and head down. Good? Right, who else has one? Who else found something that you're not sure about, but we need to talk about? Yeah, Heather? 15. So, now the first thing we notice about the problem that it has a 2x and an x, and that is not good. So, I'm going to change my 2x. Now, this is one that's a little bit tricky, because cosine 2x actually has 3 versions. Which one do you have memorized, or do you have them all memorized? The main one is cosine squared minus sine squared. But because I know, look at my problem, so I can go ahead and do that. This isn't too good to have that in there. But what do we know about sine squared? We just talked about it. Sine squared is 1 minus cosine squared. So I'm going to go ahead and change that into 1 minus cosine squared. Because there's a cosine in this problem. And I would prefer to have just one thing in the problem, all cosines. So cleaning this mess up, it looks like I got 2 cosines, minus cosine, minus 1, double check that. Okay. Big idea, get rid of that. Right? Now, what do you want to do here? It's all cosines, that's good news. It's accurate. What is that? So cosine is negative 1/2, or cosine is 1. That's the easiest. Where is the cosine 1? And where is the cosine negative? Over here. And it's pi over 3 angle. So 2 pi over 3, 4 pi over 3, is it? All right, Patrick, all that looks good to you? How far are we gonna get on that problem if we don't know our identity? We're not going anywhere. Guys, I told you from the beginning, I know it's a lot, but it's a lot. There's nothing we can do about it. We have to learn this stuff. Right, who else has one? Yep. 9. This is a calculator problem, and all that means, that does not mean anything except our answers are not gonna come out like this. They're gonna come out numbers we don't recognize and can't deal with. Otherwise, we're gonna do the problem exactly the same way. We got 3 cosecant minus 5 equals 36. So 3 cosecant equals 41, and cosecant equals 41/3. Is my arithmetic all right? Add 5 divided by 3. Now, I don't want to color the way you process the problem. This doesn't make sense to me, so I have to think about it as sine is 3 over 41. These are not numbers that I have memorized. I do know, though, that the sine is positive here and here. And this angle right here has a sine of 3/41. So second sine, 3 divided by 41, 0.073. So then, what are the answers? Ooh. What are the answers? 0.073? Good. And then the other one will be this one, which is 3.068, is that right? Now be careful, be careful, be careful. Do we have the 0 to 2 pi thing on this problem? So what does that mean? It's not just these. It's all of these. Okay, whatever. Because 0 to 2 pi limits me to once around. I could go all the way around and get lots of different answers when that limitation isn't there. Caitlin?
In order to get the 3.068, you just added 2 pies.
No. You want this angle right here.
Yeah.
This is pi.
Oh.
So it's pi minus 0.073. Right? All right, what else do we have? Yep, 16. 16 is one of these graphs. He has graphed it for us, which is nice. And our equation is 6 cosine 2 theta. So you know enough about that, even if he hadn't graphed it. It's nice that he did, but the leaves are 6 units long. There's 4 of them. And the first one is at 0, because this is a cosine. So this makes perfectly good sense. Also, since there's 4 of them, they'll be pi over 2 apart. So if you got one at 0, doesn't it make sense? You got one at pi over 2, pi, and 3 pi over 2. So it all makes sense. But he drew it for us, that's good. All right, what am I doing? 4 labeled points. Well, actually, we're restricted to pi over 2 to pi. Okay. Portion of the given graph contains 2 pieces. One of those pieces is the portion in quadrant 4 from D to E. D is that bottom point down there. And what's the other remaining piece? Well, what I like to do, Chloe, is go ahead and evaluate the function at those 2 points. So I'm going to find the ordered pairs that go with pi over 2 and pi. So I'm going to plug in pi over 2. Plug that in. So I get 6 cosine pi. Cosine pi is -1. So this is going to be -6. Now that means, and he kind of told me this already, but that means pi over 2 gave me a negative. So the first point I'm graphing in my interval is that guy right there, which is point D. All right, now, what if I put in pi? Well, if I put in pi, I get 6 cosine 2 pi, which is 6. Or I mean, 1, so I get 6. So that is point A. Now, I he tells me that one of my things is D to E. Okay, so I think I'm good, because the first point in my interval is D, but he tells me I'm going to E. And then I know, because I calculated it, my last point is A. So if I gotta go from D to E, he told me that. Then to finish the interval, don't I have to go from E to A? Yeah. So he gave me a lot of information that was useful. Just less.
How is the 6 and the pi A? Where did he see?
Okay, where is angle pi?
Yeah.
Here's pi, and I go 6 on the pi line. Remember, that's my angle, so get on that line and go that far. There's no switching unless that guy's negative. Otherwise, you're plotted right on your angle. Put your hand up, Lily. Do you want it to be up? All right, let's go. Let's have a couple more. Is there anything else on this one? 17. 17 is another graph. Only this time he didn't graph the whole thing. This, well, we know the equation. 4 cosine 2 theta. And we're going from pi to 3 pi over 2 this time. Okay. So I think maybe I'll do the same thing. So if I plug in pi, I'm looking for my ordered pairs at pi and 3 pi over 2. Hopefully this will. Yeah. So if I put in pi, I'll have 4 cosine 2 pi, which is what? 4? Okay, now pay attention, that's 4 comma pi. So that point is over here. Right? Pi line, 4. Now let's put in 3 pi over 2. If I put in 3 pi over 2, that will be cosine 3 pi. What's cosine 3 pi? Negative 1, so won't that be negative 4? Where is that one getting plotted? Well, it should be down, but it's actually gonna be up. So my first point got plotted here, my second point got plotted here. Is there a picture that matches that? Looks like it's gotta be A. Now, if you're confused about like what's going on in the middle, it really doesn't matter because start and finish, those are the only options. But you could plot a point in between these two things, like 5 pi over 4, and it'll be 0. And so that's how you come to the middle and then you go up.
Can you do 12 on the back? Like,
Okay, hang on, we haven't gotten to the back yet.
Oh,
Okay, so are we okay with this? Get that? All right. Anything else on the front? Or not the front, but the first 18. All right, I don't see you tomorrow, but I indeed see you on Thursday, right? So for Thursday, and I mean this, last time you guys really let me down, all of you, she was all over it. You guys need to do this last page, okay, by Thursday. So when you're sitting in your 90-minute, I don't know, class that you can't stand, not this one, and you got nothing to do, get this out, get this done by Thursday, so that you can come in like Caitlin, and we'll start with your question, whatever it was, we'll start with that. But additional review, after on the back, 14 problems. We are gonna have those done by Thursday. If you don't know how to do one, it's okay. We'll talk about it on Thursday.